Hello, my name is Anna, and this is our project with Christina and Ina. We are going to tell you about data structures and how they're represented in Python and what you can do with them. Data structures in Python is a way of storing and organizing data so that they can be assessed and worked with efficiently. In Python, data structures are represented as lists, and there are two most common list types in Python, which are queues and stacks. These are the representation of the list and what you can do with them, and in the following video we will tell you more about that.
Hello, I'm Christina and I would like to tell you about using lists as stacks and as queues. First of all, let's talk about stacks. And the principle of stacks means that the last element which is added to the stack will be outputted the first one. So as you can see in this line, I create a stack and the elements of the stack are eat, sleep and dream. In the next line I use such function as append and I add an element code to the top of the stack. This is the principle of using append function. Then let's print our stack and see what happened. As you can see in the first line, we added code elements to the end of, it means to the top of our stack. Let's move on. Then I use such function as pop. It means that we remove an element from the top. As you can see in the second line, we removed our code element. So that's the main principle of using stacks. Next thing is queue. It means that the first element which is added will be the first which will be outputted. And there are actually two ways of appending and popping elements from queues. There is a slow way and a fast way. Let's discuss a slow way. I create list as a queue. So I create a queue and the elements are the same, eat, sleep and dream. And then I use append function code and it also adds an element to the queue. Then I want to remove the first element from the queue, and actually it's a slow way and not very convenient way because we should first of all shift all the elements to the right, to the left to remove the first element. It's not very convenient, as you can see, but it works. And in this line you can see that our each element is disappearing. And then the first way, we can import deck from collections and it will help us. In this line number 17 I create a deck. Then I use append function also and add code element. Then I want to remove it from this list and I use this function as pop left. It means that the left element, the most left element will be excluded. And then I use it again to remove sleep. And the result will be dream and code.
Stacks and queues are great to work with single elements in the list. Perhaps you would like to change something, to make some small alternatives, then they are great to use. But what if we want to change every element in the list according to some specific algorithm? Then list comprehension is here to help, and that's what we're going to talk about now. First, let's try to understand the logic behind list comprehensions by looking at this example. Now here I've created a list, an empty list called double. I use a for loop to fix the elements I would like to have in my list. After which I apply the append method 2 times x. So let's print out our list and see what happens. So for loops work excellently with list, but it required us to code 4 lines to achieve the desired result. And we can actually simplify the steps, and that's what list comprehension does. It allows us to operate within the list. So if you look here at this line number 6, let's see what this list comprehension says. And the first thing we do is we have to open the square brackets to create an empty list and to operate within it. The first thing to do inside is to clarify what elements we would like to include inside our list, and well, we want to include 2x. We ask ourselves for what kind of x we would like to multiply them by 2, because by now x is still not defined, and we say we want it for x in range 8, so type it in and let's see what happens. See, the result is absolutely identical. Let's now look at some more examples to get more familiarized with this comprehension. For example, I have a list of 5 elements, and I can do lots of math operations with it. For example, I want to print out x squared minus x for x in the list. That will give me 5 elements squared. I can even apply some functions to the list. For example, I can print out the absolute value of my elements. Surely can also round decimal numbers, or it can be very creative with list comprehensions actually. Just a quick example, if I import Euler's number from library math, I want to round EI for I in range 7. Its decimal digits will not exceed 7. Right. So this comprehension actually isn't hard, but its structure just might get a bit more complex depending on the complexity of list. Say, right now my list, it actually contains tuples as elements. Then perhaps you will need more perhaps you will need more clauses to define the elements. For instance, this list comprehension contains a tuple, so that I will only receive 4 pairs because my x cannot exceed 4. Right. But if you look at this case below, so this tuple contains a and b, 2 variables which are independent from each other. Thus, you'll have to specify for a and for b independently. So it's different from the x situation. To create a list comprehension for this tuple, I'll have to first say for what sort of a it is. So, for example, I'd like to have an a for a in double, which is the list that we have created previously. And for b in range 3, so for b when b equals to 0, 1, or 2, if a is greater than 5.
I'm going to tell you about nested list comprehensions, which are actually matrices, and I'm going to tell you what you can do with them using Python. In the first example, we assign matrix as a list of lists, and we print out every element from the matrix as an element of a normal list. So it brings out numbers from 1 to 8 in a normal list form. The second and the third example are quite similar because they both transpose the matrix, but in the first one we use a pair of square brackets to change the logic of the matrix. So it brings out 1, 4, 7, 2, 5, 8, and 3, 6, 9, the first elements of each bracket in the first brackets, and so on. And the third example actually is the same code, but it uses loops instead of functions. And in the last example, we actually assign a matrix without like printing every element of it. So we denote both columns and both rows, and we print out a matrix 3, 4 with all 0 elements.
So in this video, we've learned what is data structure, the components of data structure, namely stacks, queues, list comprehensions, nested list comprehensions, and how to work with them. We really hope that you've enjoyed the video, and thank you for watching.